Okay, so welcome to today's class, everyone. Today we're going to be looking at physics 1010/1015. Okay, so we are preparing for test 2. So my name is Tuta Juma. To those who don't know me, this is Discrete Learning Institute. Okay, so today our topics of focus are wake, power and energy, momentum, circular motion, and rotational wake, power and energy. Okay, so if you want to register with us, just visit discretelearning.com on Google, and then it will direct you to the website where you can register, or you can download our app from Play Store, which is Discrete Learning Institute app. Okay, so without wasting much of your time, let us go in today's class. So our first question for today is asking us to say, this is question 1. They are saying that an angle of 20 degrees is equivalent to A, 0.2 rad, B, 0.17 rad, C, 2.18 rad, D, 0.33 rad. Okay, so this is, they want us, you need to understand that this is an angle, theta. Okay, so theta, which is 20 degrees, it is also known as angular displacement. Okay, so now you need to understand that there is a way you can write the theta, or the angular displacement. You can either write it in degrees, okay, or radian measure. Okay, even revolutions you can do that. So this question is asking us to convert from degrees to what? To radian measure. So there is a conversion factor which you need to know, is that 360 degrees is equivalent to 2 pi rad. Okay, then you're going to get the angle they've given you, which is 20 degrees, and then you're going to equate to x. Then you cross multiply, you're going to have 360x is equivalent to 20 times 2 pi. When you punch in your calculator there, so you say 20 times 2 pi, it's going to give you 125.66 rads. Okay, so when you divide by the 360, even this side by the 360, so let me remove this first of all. So yes, so you're going to find that your angular displacement in radian measure is just 125.66 divided by the 360, and it's going to give you 0.349. Okay, so which is just the same as x is equals to 0.35. Okay, this is in what? In rads. So you're going to check here which one is close to this one, which is what? D. Okay, so you're going to find out that the answer for this case, it is D. Okay, all right, let us continue. Question 2. Okay, so question 2 says that a flywheel rotating at 10 revolutions per second requires a constant torque to rest by a constant torque in 15 seconds. Okay, in coming to a stop, the flywheel makes A, 150 revolutions, B, 75 revolutions, C, 600 revolutions, D, 472 revolutions. So looking at this question that they've given us, collect the data that they've given you. Okay, so we're going to collect the data which they've given us. They've given us to say that this flywheel is rotating. So now we need to understand that our W initial, which is our omega initial, is what? Our initial angular velocity. It is equivalent to 10 revolutions per second. Okay, so now they are saying that it requires a constant torque. A torque is it's the same as momentum. It's the turning effect of a force. So in short, it is a rotational force. Okay, torque is more like a rotational force. So now this torque is required for this flywheel to come to a stop, meaning that W final is equals to what? 0 revolutions per second. Then now, the time they've given us for this torque to cause this flywheel to come to a stop, it is what? The time is equals to 15 seconds. Okay. Now, they want us to find the number of in short, they're telling us to find the what? The angular displacement. Okay, that is what they want us to do, what? To find. So from all those three equations of motion, we can be able to calculate what? The theta. Okay, but before you calculate the theta, you need to have what? You need to have acceleration, and this time this is what? Angular acceleration. So you're going to say that angular acceleration is equals to W final minus W initial over the time taken. Therefore, our acceleration is equals to W final, it is 0, minus initial, it is 10 revolutions per second. Okay, divided by the time, which is just 15 seconds. Therefore, your angular acceleration is going to be equals to, when you divide the 10 and the 15, so 10 divided by 15 is going to give us 0.67 revolutions per square second. Okay, so now you can convert these revolutions to rads. Okay, that is the best thing you can do, or just leave it like that, because your answer is going to be what? In revolutions. Therefore, you are going to say, since they want you to find the theta, okay, so you're going to look at from those equations of motion which one has theta. So the second equation of motion and the third equation of motion, they have what? They have the theta. Okay, and we know that from translation we have change in S is equals to V initial t plus 1 over 2, and then we have acceleration time squared. Then in a case where we have the other one is Vf squared is equals to V initial squared plus 2 a change in S. Okay, so this is in what? In linear motion. But in angular motion, you're going to have change in theta. Okay, where there's S, we add the theta there. Then it's going to be W initial, or you can add the 0 if you want to use the 0 here. So this one, then t plus 1 over 2 angular acceleration t squared. Then for this one, you're going to have W final squared is equals to V initial square, like this, plus 2 change in what? In theta. Okay, so that is what you're going to have. So you have your acceleration there, you have your initial angular velocity, your final angular velocity, you have the time there, so you can use any of the two. Okay, so because of that, let us use the first one. So we'll say that change in theta is equals to the initial angular momentum or angular velocity. It was so let us just convert it. No, since we already have everything is in the same unit, so it's fine. Okay, so it's going to be 10 revolutions. So just say 10 times the time. It is what? It is 15. Then plus 1 over 2. The angular acceleration is 0.67. Okay, and then the time is just 15 squared. Therefore, your change in theta is going to be equals to, this is going to be 150 plus, and then this one here, it is going to be 1 over 2. Oh, and the answer here is supposed to have a negative. Sorry for that. Here, supposed to be negative, because 0 minus this, it will be negative 0.67. Okay. Therefore, here I'm going to have, so here I'll add the negative. Okay, so I'm going to have negative 0.67 multiplying with the 225. Okay, therefore, my change in theta is going to be equals to, when I multiply 0.67 times 225, it is giving me 150. 150 then divided by 2, it will give me a 75. So it will be 150 minus 75.375. Okay, after I have done everything this side, I've gotten this one. Then my change in theta is going to be equals to 150 minus 75.375. It is going to give me a 74.625, which is just the same as change in theta is equals to 75 revolutions. Okay, are we together, everyone?
Yes.
So the answer is B. Okay, so that's what you do for this. So this one is constant angular, this is constant angular motion or constant circular motion. Okay, so that is how you solve this question. So make sure that the units are the same. They are the same like this one. That's why I didn't do any conversion, because they were the same. So even if I was to plug in, meaning that the answer will come out to be in revolutions. Okay, question 3. A hoop, ring, and a disc, a flat circular plate of the same mass and radius, roll down an inclined plane. At the bottom, they have the same A, kinetic energy of rotation, B, angular speed, C, gravitational potential, D, angular momentum. What's the answer? What's the answer? At the bottom, what are they going to have at the bottom when they are down? Here on an inclined plane, there are 2. Okay, so they will be going down. But when they reach down here, what are they going to have, which will be the same? Yes, they're going to have the same gravitational potential energy, because from here, the gravitational potential energy will be converted to kinetic energy. Okay, when it is at the bottom here. So you find out that the potential energy here, at the bottom, it will be 0. Okay, if it just reaches at the bottom here, because there's no height here, so it will be 0, and for both cases it will be 0. Okay, then the kinetic energy, it will have 2, because here we're dealing with rotational motion. Okay, so we're going to have kinetic energy, which is in a straight path, which is translational, and we're also going to have kinetic energy, which is rotational. Okay, there will be that conversion. That's under rotational work, power, and energy. Okay, wonderful. Let us look at question 4. Water is pouring down a waterfall at a rate of 100 kg per second as the blades of a turbine rotate to generate electricity. If the height of the fall is 100 meters, the power delivered to the turbine is approximately equal to A, 100 watts, B, 100 kilowatts, C, 1 kilowatts, D, 10 kilowatts. Okay, so you check the data that they've given us. So the data they've given us here is that they've given us number 1, they've given us a rate. Okay, this rate, it's 100 kgs per second. Okay, so we have that rate. Now we also have a height, okay, a height which is 100 meters. Now another thing that you have, because you're dealing with height, meaning that there is a presence of gravitational gravitational acceleration, which is just 9.8 meters per square second. Okay, so looking at what we've been given, so here they want us to find power. We know that power is equals to work over time. Now here we don't have work, okay, we don't have work, but we know that work is equals to force times the distance, okay, or in this case it is the height. Okay, so since in this case it is the height, so we say force times height, then divided by the time. But we don't have a force, but you are also going to realize that power is equals to the force. What force is acting here? Okay, so there's a force which is a gravitational force. Okay, so this gravitational force, it is mg, okay, h over t. Now here we have been given the mass and the time, because they've given us a rate which is comprising of power is equals to mass over time. This is the rate, okay. So we're going to say m over t times the gravitational force times the height, and that will give us our power. So power will be equals to mass over t, which is just 100 kgs per second, times the gravitational force, which has been 99.8 meters per square second, times the height, which is just 100 meters. Therefore power will be equals to, when you multiply that, it's going to give you 100 times 9.8 times 100, which will just give us 98 okay, 98,000 watts. Now when you look at these answers which are here, they have been they have been rounded off. Okay, so if we round off this one which we've gotten here, we're going to have power is equals to 100 watts, which can also be written as power is equals to 100 kilowatts. Okay, so which is our answer here is what? It is B. Are we together? Are we together, everyone? Hello, is it clear? Oh, okay, let me repeat. So the question was saying that water is pouring down a waterfall, okay, at a rate of 100 kgs per second, as the blades of the turbine rotate to generate what? Electricity. If the height of the fall is 100 meters, the power delivered to the turbine is approximately equal to, so we know that power is equals to work over time, because it is the rate of doing work. Now we don't have work, they've not given us work, but they've just given us this information here. Okay, just a minute. Okay, so as I was saying, they've just given us this information here. Okay, and then here we have this formula. So now we don't have work, but this work formula, we know that work is the product of force times distance, but the distance which has been covered, it is the distance in the y-axis. So because the distance in the y-axis, it is a height. Okay, so we say that work is equals to force times height. So we replaced it here, but we don't have the force again. But we know that force, what kind of force is acting on this water which is pouring down? It is a gravitational force. So we know that gravitational force is equals to mg. It is the weight force, in short. So we replace the force with mg, okay, times the height over the time taken. Now, the rate which they've told us here, they say that at a rate of 100 kgs per second, meaning that it has mass over time. And then here we have mass, gravity, and the height. So I just separated this one and this one because it is representing the what? The rate. So I removed the m over t and I place it like this. M over t times the g times the height. Okay, that's what I did. Then, because m over t is representing the rate, I just got the rate which was 100 kgs per watt per second and I placed it here. Then I multiplied times the gravitational force which is 9.8, or gravitational acceleration which is 9.8. I placed it here times the 100 meters. Then I multiplied everything here. I got 98,000 watts. Then my P is equals to 100,000 watts. As a result, I wrote it with a prefix kilo and it became 100 kilowatts. Is it clear now? Is it clear before we move forward?
Yes, sir.
All right. So now, question 5. A ball A of mass m moving with a certain kinetic energy makes an elastic collision with a second ball B initially at rest. If the maximum energy of A is transferred to B by the collision, then B must have A mass much larger than A, B a mass much less than A, C a mass equal to that of A, D an infinity mass. What's the answer?
C.
C, right? Yes. So for a maximum energy to be transferred from A to B, meaning that the masses are identical. Okay, that is why that happens. So question 6. A dropped stone loses potential energy as it falls. Gravity is an example of A. Dissipative force, B. Conservative force, C. Non-conservative force, D. Any of the above depending on the reference level. Gravity is an example of which type of force? Yes, it's a conservative force. Okay. Okay, question 8. A perfectly elastic sphere traveling with a velocity v strikes directly an identical sphere originally at rest. With what velocity will the latter sphere move after the collision? A. V over 2, B. V, C. V over 3, D. the square root of V over 2. Anyone? Okay, so the answer here is V, which is similar to this. There's a question we answered here. Yes, 5. If you check 5, swap the questions. So if you check 5, 5, it says that for A to transfer all its energy to B, B must have what? An identical what? Must have the same mass. So now in this case, they are saying that this sphere, okay, it is moving, and these two spheres, they are identical, meaning that they have the same mass. So now when it hits one of the ball or one of the spheres, what is going to happen is that this sphere is going to transfer all its energy to the other sphere. Okay, so because that happens, even the velocity, this one was, if this one was at a stop at 0, the ball which is moving here is the one which is going to get the 0, and then this one is going to get the velocity if it is what? Elastic collision. Okay, so this is usually seen in pool. Okay, those who play pool, sometimes you hit a ball, you find out that this one stops and then the other one goes and it enters the what? A pot. So for that case, that is why it happens like that. Okay, are we together? All right, so I swapped the questions here. So now question 5 or question 7, a 5 kg mass is held above the floor for 10 seconds. The work done is A, 200 joules, B, 0, C, 20 watts, D, 200 watts. What's the answer? So this is you. You are holding. Okay, let me just use this. Then this is the 5 kg object. Yes?
0, sir.
Yes, it is 0. So no matter how long you might hold this, as long as there's no any movement either in the Y or in the X direction, then you've just held it, you've done no work. Okay, that is what I wanted to explain. So here, as long as this is not either moving up to cover some work in the Y direction, or it's not moving in the X direction to cover some work in the X direction, it is covering 0 work. Okay, that is one thing you need to understand. So even those people who carry buckets on their head, in physics, no work is what is done. But when lifting the bucket on the head, that because you're lifting it from the floor, then you're taking it up to your height. So that distance, you have done some work. But if it, as long as it's on your head, as long as you're moving, no distance is being covered in the either in the X or in the Y, that one there, you are not doing any work. Okay, so that is the reason why. Question 9. The angular momentum of a physical system is conserved. Okay, the angular momentum of a physical system is conserved. A, when the net externally applied torques on the system is 0. B, when the net externally applied force on the system is 0. C, when the angular velocity of the system remains constant. D, when external forces are acting on the system. What's the answer?
B.
B? No. Okay. So the answer is A. So this is angular momentum. Okay. So you're dealing with torque. So you're dealing a motion in a circular path. Okay. So the answer is when the net externally applied torques, okay, on the system is 0. That's when you're going to have what? You're going to have the angular momentum to be what? Conserved. Question 10. Momentum is closely related to A. Kinetic energy, B. Potential energy, C. Impulse, and D. Power.
The impulse.
Impulse.
Yes, it's impulse, correct. So you need to understand that impulse is just the change in what? Momentum. Okay. Impulse is just a change in momentum, meaning that impulse is just P final minus P initial. Okay. Wonderful. Question 11. A ball of mass of 0.1 kg has a velocity of 5 meters per second. It strikes a wall perpendicularly and bounces off straight back with a velocity of 3 meters per second. The ball undergoes a change in momentum equal to dash. Okay. Equal to dash. So you need to understand that change in momentum, okay, is equals to P final minus P initial. Okay. So change in momentum is equals to, what's the P final? So P final, it was, so this one, so you need to understand that in momentum, direction is very, very important. So this one is in the positive direction, then this one is in the negative direction. So now, if it is moving this side, you're going to say that in the final, it was what? It was negative 3, okay? Negative 3, which is or let me just say, the mass is what? It is 0.15. Or let me just do this. Okay, so change in momentum is equals to mv initial. Since it's the same object, so I'll say again minus, mv final minus mv initial. Then change in momentum will be equals to mv final minus v initial. Then the change in momentum is equals to the mass, it is 0.15 kgs. Okay, then now, or let me just write 0.15. Then the VF, it is negative 0. Negative 3. Okay, so it is negative 3. Then minus the initial velocity was what? 5. Okay, which was just positive 5. As a result, the change in momentum will be equals to 0.15. Okay, then here I'm going to have negative 8. Then the change in momentum will be equals to 0.15 times 8. It's going to give me a 1.20 kgs dot meters per second. Okay. Okay. Is it clear? So the answer is B. So here we're getting a negative answer because of how I've used the directions. Okay, if I chose this one to be negative, this one to be positive, I would have gotten a positive one. Okay. Are we together, everyone, on this? Okay, let us continue. Question 12. A box is put along a smooth floor by a force F, making angle theta. with the horizontal. As the angle theta increases, the amount of work done to pull the box in the same direction, in the same distance d, A increases, B remains the same, C decreases and then increases, D decreases. What happens? What? I didn't get you. Decreases. Okay. So you can just test this one. You know that work is equals to the product of force times distance, then cos theta. Okay. So you can just say, let us assume that our force is equals to 5 newtons. Okay. Then our thetas, which we're going to take 2 thetas. So I'll get when I have cos, so I'll have the first angle I'm going to have is a 0. Okay. Then when I have theta being equals to 60. Okay. What will be my so this one is 0 degrees, on is 60 degrees. Okay. So when I say work is equals to force, so the force is the distance here I have, in this case it's equals to 2. Okay, 2 meters. So I'm going to have force is equals to, so this work is equals to force, which is 5 times the 2, then cos, I'll get the first angle, which is 0, and then I'm going to get my work to be equals to a 10 joules. Okay, now what if I use 60? I'm going to have work is equals to force, which is 5, times the distance, which is 2, times cos, times the angle, which is a 60. I am going to get a 2.5 joules. Okay, so from here I'm able to see that when the angle increases, when the angle theta increases, the work decreases. Okay, but when it reduces, like for example it becomes 0 degrees, the work does what? The work increases. You can test with any other 2 angles, you still find the same thing. Are we together, everyone?
Yes, sir.
All right. Let us look at question 13. Question 13, it says that a 2 kg mass moving with a velocity of 7 meters per second collides with a 4 kg mass moving in the opposite direction at 4 meters per second. The 2 kg mass reverses direction after collision, okay, and has a new velocity of 3 meters per second. What is the new velocity of the 4 kg mass? Okay. So in this case, we're going to say that this is, so we have initial momentum, it must be equals to final momentum. Okay, so initially we had a ball, a mass, okay, a mass of 2 kg, so we had so m1 times v1. Okay, then it interacted with another mass, which is m2 v2. Okay, it was equals to so this one was initial, then this other one it had to say m1 v1 final plus m2 v2 final. Okay, yes,
So I don't know if it's my network, so I can't hear. I can just yeah.
Oh, you can't see my screen. Just
That's fine now.
oh, okay. So P initial must be equals to P final. So I have my M initial and my V1 initial. Okay, or I have my M1 and my V1 initial. Now, what information have I been given? I have been given this information. I have also been given this information. Then I have also been given this information, but I have not been given this information, which is here. Okay, so in this case, what we are going to say is that M1 is what? It's 2 kg. So I'll say 2 kg. So I want to add the kgs. I'll just say 2 times the V1 initial. It was what? 7. So V1 initial 7. Then plus the 4 kg, which was 4 times it was moving at 4. Okay. Then it was equal to the 2 kg now. So 2 times it was moving at another velocity, which was 3. But listen to this. Here when I'm multiplying 4 kg, they are saying that this 4 kg mass was moving in the opposite direction. Okay? So direction is very, very important when it comes to momentum. So here I'll add negative what? Negative 4. Okay. Then here V1 final, it is just, so V1 final in this case, it is going to be 3. Okay. So check the 2 kg mass direction after the collision. Okay, reverses direction. So the direction has been reversed. So instead of going to the positive direction, it has changed. Now it's moving to the negative side. Okay. Oh, and it's in negative 3. So plus M2, we know that it is 4 times the V2F. Okay. So as a result, you're going to say 2 times 7, that will be a 14. Then this is going to be plus negative 16. Then is equals to negative 6 plus 4 V2F. Okay. So now in this side, I'm going to have negative 2 is equals to negative 6 plus V2F. Okay. Then the negative 6 comes this side. I'm going to have negative 2. Negative 2 plus the 6 is equals to 4 V2F. Okay. As a result, negative 2 plus 6, it will be a 4 is equals to 4 V2F. When I divide the 4 this side and this side the 4, I'm going to get a V2F equals to a 1, which is what? Positive 1 meters per second. So meaning our answer in this case, it is what? It is C, which is here. Are we together?
Activity stopped.
Are we together, everyone?
Yes, sir.
Yes.
All right, wonderful. So question 14. An object at rest may have A, momentum, B, velocity.
Sir, please repeat.
Oh, okay. So let me just repeat. So when you have been given a momentum question, you need to understand that in momentum is always conserved, meaning that initial momentum must always be equal to final momentum. So in this case, we have the initial incidence that was happening is that a 2 kg mass was moving at 7 meters per second. Okay, in a particular direction. So we've mentioned this one to be a positive direction. Then it collided with another mass which was 4 kg, and this other mass was moving in an opposite direction, meaning that it was moving in a negative direction. Okay, so when they collided, so that was the initial circumstance that was happening. Okay, then now after the collision, that is when now we go to this side, we had the mass and the new what? The new velocity. Okay, so they are saying that the 2 kg mass reverses direction, meaning that it has changed direction after the collision. Okay, and it is moving at a new velocity, which is what? 3 meters per second. So meaning that this 3 meters per second, this one, it was in the positive, this one will be in the negative. Okay, then they're asking us to say what is the new velocity of the 4 kg mass. So now the 4 kg mass was moving in a negative direction. So you have that information. So you don't know what the V2 final, you don't know for the 4 kg mass. You don't know what at what speed it is what it is moving. Okay, so a general question they would give you, it is to always know, they need to specify if it was perfect elastic collision or it was inelastic collision. But in this case, we've identified that these have collided and they are both moving at different velocities, but it is not inelastic. It is not like perfect inelastic where they've attached to each other. No, it's in an elastic case. Okay, but it's not that perfect inelastic case where everything is conserved. Okay, so now this one, they've just hit each other, then this one is moving at its own speed, this one is also moving at its own speed and in their own directions. Okay, so we've identified that. So we just started plugging in. I got the 2 kg mass which they gave me, which was this one. So I plugged it in here. I said 2 times the v1 initial, the velocity at which it was moving initially. So it was 2 times the 7, and it was what? Positive, like we mentioned. Then now, that was for the first part, for the first mass. Then the other mass was M2. M2 is 4 kg. 4 kg was moving the opposite direction, which was what? Negative 4. So I placed here, you say 4 times negative 4. Then I said equals to. Then now, after the collision, M2, they've said that it was M2, which was 2, or M1, which is 2 kg, 2 times, it changed the direction. We know that it was moving to the positive direction, but it changed to the negative direction. When it changed to the negative direction, it had a new velocity, which was what? 3. So meaning that it is negative 3. So then plus 4. We don't know at what this one is moving. It's what they are asking us to do, what? To find. So therefore, after I plugged in, I just solved simplified. This is 2 times 7. This is 4 times this. This is this times this. As a result, I got a 14 here. Here I got a negative 16 is equals to negative 6 plus 4 V2F. Okay. After doing that, this side I had a negative 2. And then this side I had negative 6 plus 4 V2F. Then the 6 came this side. I had negative 2 plus 6 is equals to 4 V2F. Then this side I had a 4 over 4. And then it was equals to 4 V2F over 4. As a result, when I divided, I got a 1, which is just positive what? Positive 1. As a result, my final velocity for the 4 kg mass was 1 meter per second, which was what? Positive. Are we together?
Yes.
All right, wonderful. So question 14. An object at rest may have A, momentum, B, velocity, C, kinetic energy, D, potential energy.
Potential.
Yes, wonderful, correct. So potential energy is the energy an object has at rest. Okay, for those objects that are at rest. So if, for example, this is a rock which is on a mountain. Okay, this is a mountain, regardless of how it looks. So this is a mountain, so this is a rock. So this one has a potential energy, okay, depending on the height that is here. Okay, but it is not moving. So it cannot have momentum because momentum is mass times velocity, meaning that it's moving. So something that race is not moving. Velocity, it's something that is moving. Kinetic energy, you can never have kinetic energy without motion. You know that kinetic energy is for objects at 10. Is the energy that a moving object has. Okay. So our answer is D. Then now, the product of torque and the angular displacement through the torque axis is called A. Rotational inertia, B. Moment of inertia, C. Radius of gyration, D. Wake.
Yes, moment of inertia.
No? So you have torque.
Radius of gyration.
No? So you have torque multiplying with the angular displacement theta. Torque is a force, right? So force, then angular displacement is displacement. Which formula is like this?
Wake.
That's for wake.
So this is in translational motion. Now this one is in rotational motion. Okay, so in rotational motion, force is the what? I can say force is more like the analog of what? Of torque. Then for displacement, theta is the analog of what? Of displacement. So meaning that here it's actually supposed to have a rotation or something, it's a rotational wake. Okay, so here we have wake, it's the one which is equals to torque times the theta. Okay, so rotational motion mostly it has its analogs, okay, with the translational motion. So that's the way you can. So for example, if you have like angular acceleration, okay, angular acceleration is equals to acceleration times r. Even this torque, it is just equals to the tangential force times the r. Okay, then even the theta is equals to s over r. You are able to see all these because of the radius, because it has a radius, that's why it is now in a circular path. So the answer is D. Are we together?
Yes.
So question 16. Which of the following is not a unit of power? A. Joules second, B. Watt, C. Newton meter per second, D. Horsepower. So we know that horsepower is a unit. Oh, yes? Someone has an answer? A? So the answer is A. Okay? So Joules second is not a unit. The unit is Joule per second. Okay? But this one is Joule second. So it's the only one which is not a unit. But what is a unit? Newton meter per second is a unit, because when we say that power is equals to work over time, this is equals to force times distance over time, which is just this one is Newton, the distance is meter per second. Okay, derived units. So all this, that's how you can get to have the units of power. So the answer is A. Question 17. The amount of work a 0.6 kilowatt electric drill can do in 1.0 minutes is A. 36 joules, B. 0.6 joules, C 0.6 kilojoules, D 36 kilojoules. Okay, so collect the data. So from the data they've given us to say that the time is equals to 1 minute, which you can convert. So 1 minute, you say times 60 seconds over 1 minute. Then what about the work? Work is equals to 0.60 kilowatts. Oh, this is power. Sorry. So this is power. So power is equals to 0.60 kilowatts. Then what about our work? We don't know. So therefore we say that work is equals to power over time, which is power over time. So our power is equals to 0.6 kilo. It means meaning that I have a 600 watts, because a kilowatt is just like 0.60 times 1,000. Okay, watts. As a result, this is just the same as 600 watts. So here I have 600 watts divided by the time taken, which is just 60 seconds. As a result, I'm going to have this goes, I'm going to have a 6 into 6, that would be 1 point, not 1.10 joules. Okay, so in this case,
Sir, are we not supposed to multiply power with time? Because power is equal to work over time, and then when we make work to be the subject of the formula, it will be power multiplied by time.
oh, the question is asking us to find work. Oh,
Yes,
thank
when
you,
we
thank you,
make
thank you, thank you
work
very
is the
much.
subject of the formula, it will be power time
I've seen
times
power
time.
is equals to work over time. Thank you. I swapped everything. Okay, so meaning that work is equals to power times time. Thank you. So work is equals to, what's my power, which is just 600 watts, times the time, which is just 60 seconds. Okay, so my work is equals to 3,600 joules, which is just work is equals to 3 point, again this is there's a problem here somewhere. Okay, because if we have that, we're going to have 3.6 kilojoules. Here it's supposed to be a point. Let me do this question just as an error.
So the answer is 86,000, not 3,600.
All right. Thank you. So okay, thank you very much. Don't know what happened. Okay, all right, let us continue. Is it clear? Or someone has a question? So the answer is D. Okay, I'll use my calculator now. I'll use my calculator now. Okay, all right, let us continue. So to know how many minutes we still remain with. Okay, we have 15 minutes. Okay, so question 18. Okay, so this one is on those questions which they are 5 marks each. So I'm sure you, when you wrote from your test 1, you saw how they bring 25 MCQs. Then there are questions where you answer, then you just write an answer. They're just interested in the answer, okay, not in the process. So it's 5 marks per question. So question 18, it's saying that a disk rotating at 30 rads per second slows to 20 rads per second while turning through 60 revolutions. How long does it take to make the 60 revolutions? Okay, so the first thing that we do in this case, we collect the data. Okay, they've given us initial angular velocity, which is equals to 30 rads per second. Okay, then they've given us our final angular velocity, which is what? 20 rads per second. So from what we are seeing here, this one was what? Decelerating. So what is our angular acceleration? We don't know. Okay, then what have we been given as well? We've also been given to say our theta is equals to 60 revolutions. We have been given 60 revolutions, which can be converted to say 2 pi rad over 1 revolution. Okay, so that the revolution goes and your theta is equals to 60 times the 2, which is just 376.99 rads. Okay, then what do they want us to find? They want us to find the time. Okay, how long does it take to make the what? So now here just a minute. Okay, so the first thing we're going to do is to calculate for what? Our acceleration. Okay, so from those 3 equations of motion, which we know in linear motion, okay, we know that in linear motion we have this equation. Okay, I was examining the equation. So 2 plus 2, a change in s. Okay, so here I've been given the change in s, which is this one here. Okay, so now, but this one is in linear motion. So in angular motion, you're going to have W final squared is equals to W initial squared plus 2 this change in what? Change in theta. Okay, so now here we are finding the change in theta. We are finding the acceleration. So what you can do, you can take this one this side, you're going to have WF squared is equal WF squared minus W initial squared is equals to 2 alpha change in theta. Then when you divide here, you're going to have 2 change in theta, even this side 2 change in theta. Okay, then this goes, your alpha is going to be equals to WF squared minus W initial squared over 2 change in what? In theta. Therefore, your angular acceleration is going to be equals to, what was your final? It was 20 rads per second minus this one was 30 rads per second. Okay, over 2. Then your change in theta is 376.99 0.99 rads. Okay, therefore your angular acceleration will be equals to 20 minus 30, that is a negative 10, divided by 2 times 376.99. Okay, what are we getting? We are getting an acceleration of negative 0.013. Okay, 0.013. Okay, which is in rads per square second. So this is our acceleration. So they want us to find the time. So what you're going to do is that since now you have the acceleration, what you can do now, you can use another equation, which is we know this one, v is equals to, or v final is equals to v initial plus acceleration time, where you can just change this and come this side. You're going to have v final minus v initial is equals to acceleration time. You divide by the acceleration, even inside by, oh, not this, at. Okay, before I add the, so you divide the acceleration, even this side acceleration. There your t is going to be equals to v final minus v initial over acceleration. Now this is in what? In linear motion. Okay, this is in linear motion. So since this is in linear motion, we are going to have now time is equals to wf minus w initial over alpha. So t is equals to w final, it was negative what? Negative 20, oh, not negative 20, it was 20 minus this one initial, it was 30. Okay, so you can just add the units. So rads per second minus this one here, you're going to have 30 rads per second over the alpha, which is just 0, so negative 0.013 rads per square second. Okay, therefore your time will be equals to negative 10 rads per second over negative 0.013 rads per square second. Then when you divide there, you're going to have, so when you divide negative 10 divided by negative 0.13 or 0.013, we are getting the time, it will be 769.2 seconds. Are we together?
Yes, sir.
Okay, wonderful. So that's what you do. So again here there's another question, question 19. They are saying that a 60 kg box is pushed 12 meters across a horizontal floor by a force of 200 newtons. The coefficient of kinetic friction is 0.3. How much work went into overcoming the friction? Okay, so we know that there is work done by the object. Okay, there is some work which will be done by the object, but we also have, so there is a total work done. The total work done, it is we're going to have total work done. So work total is equals to work done by the what? The force minus the work done by the what? The friction. So now what they want, it is to find the friction force. Okay, that work that has been applied into the friction force, that is what they want us to do, what? To find. Okay, so therefore we are going to say that work done by friction is equals to, because we need to overcome this friction. Okay, so because we need to overcome this friction, it is the friction, the work done by the object to overcome the friction is equal to the work done by the same friction, such that they are going to cancel out each other, so that you can have the work total. Okay, so work done by friction is equals to the friction force times the distance, okay, cos theta. So now friction force is equals to mu's of, this is kinetic, so it's mu's of k normal force. Now, what is the normal force? This is the horizontal flow. Okay, this is the body. So now the normal force is the force applied by the surface towards the object. So this is the normal force. Now here, this body, if there's a force which is pushing down, and this is the weight force, which is what? Mg. Okay, so since this body is neither going up nor going down, but it is on the surface, which is just down like that. So the friction force here, or the normal force, is equals to the what? To the weight force. Okay, so meaning that the normal force is equals to mg. So it will be positive because it's going up, then this one will be negative because it's going what? Going down. As a result, they are going to cancel each other. So this is positive mg and this is negative mg. As a result, they give us a 0. That's why the body is neither going up nor going down. So our friction force in this case, it will be equals to our mu's of k. They've told us that our kinetic friction, our coefficient, it's a mu's of k, which is 0. What? 0.3. Then our normal force, it is just Fn equals to what? Mg. So what is our mass? Our mass is 60 kg. So this box is 60 kg. So we are going to say that our normal force is mu's of k, or our normal force is equals to mg. So which is just the mass, which is 60, times the gravity, which is 9.8. Therefore, our friction force will be equals to, when you multiply 0.3 times 60 times the 9.8, it will give us 176.4 newtons. Then now, the question is asking us to find the work to overcome the friction, which is the same as work done by what? By friction. So work done is equals to the friction force times the distance which was covered, which was what? 12 meters. So it's going to be work to overcome the friction is equals to the friction force which was to be overcome. It was 176, okay, 0.4 newtons times, okay, times the distance, which was what? A 12. So don't forget, here there is cos, sorry, here there is cos theta. Okay, don't forget that formula. So our friction force times the distance cos theta, so I'm going to have 176.4 newtons times the 12 meters, then cos, what is our angle? Friction force is in the opposite, so it's cos 180. So our work done by the friction force is equals to, when you multiply 176.4 times the 12, okay, it will give us 2116.8, okay, times the cos 180, it will give us a negative 2116.8, okay, joules. So this is the work done to overcome the what? The friction. Okay, are we together? Are we together, everyone? Are we together before we move forward?
Yes, sir.
All right. So this is 22. Okay, so we'll just end here.